So now we're going to start section 6.2. In section 6.1, we created confidence intervals for a mean based off of knowing the population standard deviation. That's not always going to be the case, and so we need to look at what happens when you are using a point estimate for the standard deviation as well as for the mean. And if that's the case, we're going to use something called the t distribution in place of the z distribution. So in other words, instead of using z-scores for our critical values, we will be using t-scores. This will be a more conservative estimate for the interval. Since sigma is being estimated by S. So we want to look at what the differences are before we get into this between the t distribution and the z distribution. So and this is actually in your Module 3 document, to look at some of the differences between the t-score and the z-score, and we want to look at a z. In a z, we did x bar minus mu over sigma over the square root of n, whereas a t-score for the t distribution is calculated using x bar minus mu over s over the square root of n. So when we start talking about the critical values and the properties of the t distribution, the mean, median, and mode of the t distribution are all equal to 0, just like it is in the z. The t distribution is bell-shaped and symmetric about the mean, just like it was with the z. The total area under a t curve is 1 or 100%, again, just like the z distribution. The tails in the t distribution are thicker than those in the standard normal distribution. And so you'll notice in this picture down here when we get to number 7 what I mean by that. The standard deviation of the t distribution varies with the sample size. The t distribution is a family of curves, each determined by a parameter called the degrees of freedom. And the degrees of freedom is equal to the sample size minus 1. So when we get down to number 7, as the degrees of freedom increase, the t distribution approaches the normal distribution or the z distribution. So as n gets larger, the t curve gets closer and closer to the z curve. For large degrees of freedom, critical values for the t distribution are close to corresponding critical values for the normal distribution. For large n, t sub c's are close to your z sub c. And so what you'll see in the table that I'm going to show you, the value in the last row of the table marked infinity corresponds exactly to the normal distribution. So let me show you what happens in a t distribution and how that looks relative to the relative to the z curve. In Moodle, you will notice at the top of where these videos will be for chapter 6, there is a formulas and t-chart for test 3. And if you click on that, one of the things that you will see is the t distribution chart. So let's look at this. So just like confidence intervals for z's, we could calculate this negative and positive z-score. So now we're going to do that for the t-score. I want to draw your attention down to the bottom of this chart, this infinity line that I just made reference to. 1.645, 1.96, 2.576. Those numbers should look familiar. And if you look up here at the top of this chart, and we will be using this chart for both chapters 6 and 7, that's why there's extra stuff up here. But if you look at the top of the chart, it'll give you the confidence levels. So for 90% confidence, our z-score, if you'll remember from 6.1, was 1.645. For 95% confidence, it was 1.96. And for 99% confidence, it was 2.576. So having this chart, you don't have to calculate these specific confidence levels to get the z-score if it's a problem like the ones we saw in section 6.1. But in 6.2, when we deal with the t distribution, that is dependent upon sample size and degrees of freedom. So you're going to take your sample size, you're going to subtract 1, and you'll get a number that you will look up in this left-hand column of the chart. Once you get down here to 50, notice 50, then 60, there's very little change, only in 3/10,000ths of a difference, because you'll notice as these degrees of freedom get higher, these numbers get closer and closer to what they are for the z-score. So once you get a higher n value, your degrees of freedom are high, your t-scores don't vary that much from your z-scores at all. But if you end up with a sample size that falls in between one of these, always round down. So if I got a degrees of freedom of 74, you would go down to 70. If I got a degrees of freedom of 58, I would still go down to 50. You're not going to round according to rounding rules. You are going to use the last one that is on the chart. So going back to our document here. It wants to be difficult, so we'll just go back to our notes. For the t distribution, that's going to be used whenever you are doing a confidence interval for the mean when sigma is unknown. The only standard deviation you know is for the sample. Sometimes people think that you have to know the, if you know a standard deviation, you're going to use Z, and if you don't know the standard deviation, you're going to use T. That's not the case. It's not whether you know the standard deviation or not. It's whether you know the population standard deviation or you know the sample standard deviation. Now, one of the things, hopefully you're listening to this second video, because one of the things that I didn't go over in section 6.1 is how to do all this on the calculator. I just did it by hand. But I'm going to show you how to do this on the calculator, and I will go back to section 6.1 type of problems and show you the difference in where to find these functions on the calculator. Remember, if we are doing a confidence interval for the mean, actually, let me go back to the original. We're going to use the point estimate plus or minus the critical value times the standard deviation of the point estimate. So in this case, it's going to be X bar plus or minus. Instead of a Z critical value, we're going to use the T critical value. And remember, that is going to be based on degrees of freedom equal to n minus 1. And then that will be multiplied by S over the square root of n. So, to look at an example, the average salary for firemen is $32,000 for a sample of 25. The sample standard deviation. Actually, let me rewrite this. Hold on one second. In a sample of 25 firemen, the average salary was $32,000 with a standard deviation of 3,600. Determine with 90% confidence what the true average salary would be. So I want to point out here that the standard deviation of 3,600 in this problem is the sample of 25 firemen's salary standard deviation. So in this case, we have N to be 25. We've got X bar, which is 32,000. We've got S, which is 3,600. And we're going to be using a T critical value at 90%. So the first thing that we need to do is figure out what that critical value would be. So N is 25. N minus 1 is 24. So we're going to go to our T distribution chart. We're going to go to 90% confidence, so that's going to be the second column. And we're going to go down to 24, and we're going to use 1.711. Because our degrees of freedom is 25 minus 1, which is 24. So we would do X bar plus or minus T sub C times S over the square root of N. So that's 32,000 plus or minus 1.711 times 3,600 over the square root of 25. Now, this is where I said I failed in the first section to show you where to do this on the calculator. So if you go to your calculator and you hit the Stat button and you go over to Tests, this is where everything from chapters 6 and 7 will be. Under Stat, going over to Tests, you can scroll down and see that number 7 is a Z interval and number 8 is a T interval. So in this problem that I'm doing, if I choose T interval, I am going to be putting in the stats. Data is what I would use if I had a list of data and I could put it in list 1 and then it would calculate everything I needed. But I actually know what the average is, which is 32,000. I know what the standard deviation is, which is 3,600. And you'll see whenever I do the Module 3 document practice what I'm doing in the calculator for the problems in 6.1 as well. N here was 25. C level is your confidence level, which is in decimals, so 0.9. And then calculate. And so what that does is that gives me the interval. So 30,768 to 33,232. So my interval is 30,768 to 33,232. And so I can say I am 90% confident the true average salary for a fireman is between $30,768 and $33,232. And like I said, when we get to actually doing the problems in the document, you'll see me go back and forth to the calculator multiple times. And that is the end of section 6.2.